Okay, today we're going to be learning Lesson 1-6, Dividing Rational Numbers. Dividing rational numbers, you are going to be using the same rules you learned for multiplying rational numbers as far as the signs go. So remember plus mountain? We call it plus mountain so that when you draw a triangle on, let's say, a quiz, you'll remember that the plus sign goes on top. And the same rules that Miss Joyce taught you in the last lesson, 1.5, are going to apply here. So the first example says, a diver needs to descend to a depth of 100 feet below sea level. She wants to do it in 5 equal descents. How far should she travel in each descent? So remember again, descend already means to go down. So if we are at a depth of 100 feet below sea level, that's a negative 100. If she wants to do it in 5 equal descents, we're trying to find out how far is each descent. In order to solve this problem, we are going to have to divide. So they set up the division problem for you. Negative 100, remember the fraction bar says divided by. What number would give us 5? So this is what we're trying to find right here. Negative 100 divided by what number? How far would she have to travel to make it in 5 descents? Remember the rules for integer multiplication. If the product is negative, one of the factors must be negative. Since the 5, the answer, is positive, the unknown factor must be what? So it's asking if I need a positive number, remember plus mountain, the factor that I'm trying to divide by, the unknown factor, should it be positive or negative? Well, remember the triangle. If I need a positive answer, I'm going to have to cover my 2 negative signs. So if one of the numbers is already negative, you know that that unknown factor also has to be negative. I want you guys to circle that. You know that 5 times negative, or you know that a positive 5 times 20 equals a positive 100. So using the rules for integer multiplication, you can say that 5 times a negative 20 would give us that negative 100. So that means that the diver should descend 20 feet in each descent. You don't want to say negative in this blank where we're actually putting the answer, because the word descend already indicates that it's negative. Okay, so to reflect what we just talked about, it's asking, what do you notice about the quotient of 2 rational numbers with different signs? So I want you guys to write in the quotient of 2 rational numbers with different signs is negative. The second question they want us to reflect on is, what do you notice about the quotient of 2 rational numbers with the same sign? Does it matter if both signs are positive or if both signs are negative? And here, go ahead and write in the quotient of 2 rational numbers with the same sign is positive. It doesn't matter if they are, we'll put there, both positive or both negative. And again, you can look at the plus mountain. So we're going to look at the placement of negative signs in quotients. Quotients can have negative signs in different places. And it's asking, are the rational numbers 12 divided by negative 4, negative 12 divided by 4, and here 12 divided by 4 with the negative sign in front of the parentheses, are they all equivalent? Are these all equal? So we're going to find each quotient separately, and then we're going to use the rules that you already know to make sure the sign of the quotient is correct. So again, the fraction bar says divided by, so 12 divided by a negative 4 would be a negative 3. So if I have a positive 12, I want to make sure you're using the plus mountain correctly. So if I have a positive 12, I cover my positive sign. If I have a negative 4, I cover my negative sign. What's left over? A negative. And that's how I know my quotient, my answer to my division problem, has to be negative. On the next one, negative 12 divided by a positive 4 also leaves me a negative 3. And on this one, you would actually do what's inside the parentheses first. So my negative sign still stays, and 12 divided by 4 is 3. So that negative sign is in front of our quotient, so it's negative 3. So what did you notice about each of my quotients that I have here? You notice that they are all the same. You could write that down. They are all the same. So that means that these rational numbers are or are not equivalent. What do you all think? Yes, they are equivalent. They are all equal. So conjecture, we're going to explain how the placement of the negative sign in the rational number affects the sign of the quotients. So what do you think? Does it matter if the negative sign is in the denominator, if it's in the numerator, or if it's in front of the entire problem? Do you all think it matters? No. So we're going to go ahead and write that down. We're going to say the sign of the quotient is not affected by the placement of the negative sign. As long as you have it on your answer. When you flip your paper over, we're going to talk about a couple of problems where you have to use the rules for dividing integers or dividing rational numbers. It says, over 5 months, Carlos wrote 5 checks for a total of $323.75 to pay for his cable service. His cable bill is in the same amount each month. That's important. What was the change in Carlos's bank account each month to pay for the cable? So he's writing 5 checks for a total of $323.75, and each time that he writes the check, it's in the same amount. So they want to know what's the change in his bank account each month. So since it's equal, it's the same amount each month, you know that it's a division problem. Well, here's one of those times when we are going to have to incorporate one of the 6th grade skills that we learned in 6th grade. And you need to know how to divide a decimal by a whole number. So you're going to divide $323.75. That is actually, you know what, before we do this, I want you guys to write negative $323. Remember that when we're paying a fee, whenever you're paying a bill or you're paying a fee, that's negative because you're taking it out of your checking account. So this is the problem that we're solving. And we're dividing by 5 because we're trying to find out how much he's paying each month. So again, the fraction bar means divided by. So when I go set up my problem, remember the top number goes inside. Remember we talked about the ice cream cone method? So this would be my ice cream going inside the freezer. When we are trying to divide a decimal by a whole number, you want to bring that decimal straight up. And then you forget that it's there. You never take it down, you just completely forget that it's there and you divide like normal. So can 5 go into 3? No. How many times does 5 go into 32? 6 times. That would be 30. Subtract, bring down. Then you continue your division. How many times can 5 go into 23? 4 times, which is 20. Subtract, bring down. You divide again. How many times can 5 go into 37? 7 times, which is 35. Subtract, bring down our last number. And how many times can 5 go into 25? 5 times. And finally, we get that 0 remainder. So this would be my answer, but again, I'm dividing a negative by a positive. So my answer, if I cover a negative sign and a positive sign on Plus Mountain, that means that my answer has to be negative $64.75 each month. That's how much, that's the change in his bank account. It decreases by $64.75 each month. Okay, in the next example, example B, they have fractions. So 7/10, remember here's our fraction bar. It's telling you divided by, 7/10 is being divided by -1/5. Okay, so again, here's another 6th grade skill that you missed, so we are going to go over it. Remember when we subtracted rational numbers with the keep it, change it, change it? Well, here we do something called keep it, change it, flip it. Keep it, change it, flip it. So I'm going to need you to make one of those charts. And these are the rules for dividing fractions, okay? We keep the first fraction. Let's set up our problem first. 7/10 divided by -1/5. Okay, we keep the first fraction the same. So that's going to stay 7/10. We change division to multiplication. And then we flip the second fraction by flipping it in reverse. Instead of -1/5, I have -5/1. And then you use the rules for multiplication that you learned in the last video, which was top times top, bottom times bottom. So if I do top times top, that's -35. Bottom times bottom, that would be 10. What's wrong with this fraction? Remember, your fractions always have to be in simplest form. This is improper. So we're going to go ahead and use division to change it to a mixed number. Again, it's going to be negative, okay? Because remember, a negative divided by a positive is going to end up being negative. So 10 goes into 35 3 times, which is 30, with how many left over? Your remainder becomes your numerator. The denominator stays the same. Well, I noticed that 5/10 could be simplified even more, so my final answer should be 3 1/2 because I went and divided by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So -3 1/2 would be my answer there. Since we went over these rules for how to divide a fraction, I'm going to have you go ahead and write those rules here because in a minute you're going to have to do it yourself on this U-Try. So I want you guys to write keep the first fraction the same. And the next bullet, I want you to change division to multiplication. And in the third bullet, I want you to write, oh, not a C, it's an F. Flip the second fraction. When you flip a fraction, it's actually called the reciprocal. Underline that. That is a good vocabulary word. So when you take a fraction like 1/5 and you flip it to 5/1, that is actually called multiplying by the reciprocal. We will go over that again. But for now, I need you guys to try everything I just taught you by yourself. So pause the video. Did you pause your video and try it by yourself? Okay, let's see how you did. In the first one, this really says 2.8 is being divided by -4. So you should have set up, remember you have to show all your work. You should have set up a division problem, 2.8 or 2 8/10 divided by a -4. You bring that decimal straight up. And then remember, you forget about it. You divide as if you were dividing whole numbers. How many times can 4 go into 28? 7 times. Well, when I multiply, that's 28. I already get my 0 remainder, so I'm done. It's just 7/10. But remember, I have a negative and a positive, so really my answer is -7/10. Box your answer. Now, here is where you had to apply the keep it, change it, flip it. So this problem says -5/8 is being divided by, I'm writing the original problem first, is being divided by -6/7. Now remember my plus mountain. If I go cover one of the negative signs on the bottom of the mountain and the other negative sign on the other bottom of the mountain, what's left at the top? What's my answer going to be? Yes, my answer is going to be positive in this case. So now that I have my division problem, I want to set up my chart. Keep it, change it, flip it. So keep it means I'm going to keep the -5/8 the same. I'm going to change division to multiplication, and I'm going to flip the 6/7. So if I take 6/7 and I flip it, I'm getting the reciprocal. So instead of 6/7, it's actually 7/6. It was negative. We're going to use the same rules for multiplication that you already learned in the last video, which is top times top would be a positive 35, and bottom times bottom, which would be a positive 48. And I'm finished because if you look at 35, the only factors of 35 are 1, 5, 7, and 35, and none of those factors share 48, or 48 doesn't share any of those factors in common. So this is in simplest form. 35/48 would be my answer. Box your answer. And on this last example, -5.5 is being divided by 0.5. And so it's a negative divided by a positive. My answer is going to end up being negative. Well, we haven't talked about dividing a decimal by a decimal, so I'm not sure if you got this right. If you did, that's fabulous. But let's try this one together, and I'll tell you what rule you need to know for this. So whenever you're dividing a decimal by a decimal, it's a little different than when you're dividing a decimal by a whole number. You have to make this outside number a whole number. So I'm going to have to move the decimal once to get it to be behind my number. Because remember, where's the decimal behind every whole number? It's in the back. So you want to move it to make that decimal go to the back. Well, whatever you do to the outside, you have to do it to the inside. So since I moved it once, I have to move this decimal once and then bring it straight up, and then forget about it. And then you can divide like normal. So how many times can 5 go into 5? Yes, once. And that's going to give us a 0 remainder, but we still have this 5 that we want to bring down. So 5 goes into this 5 once. And now we have our 0 remainder, so we are finished, except that we're dividing by a negative divided by a positive, so really this should be a negative 11. And that should be your final answer. All of these new skills that would actually be 6th grade skills that we just taught you, we will keep reviewing in class. If there's anything again that was confusing to you, please write down your questions, let us know, and we will keep going over these and practicing until you feel comfortable. See you tomorrow.